Welcome back to Mr.BitUT channel. Humanity has lived on Earth for thousands of years with the question, is there anyone else out there? In the eerie silence of space, our blue planet seems to be only a small, isolated bright dot among billions of celestial bodies. Yet it is precisely this solitude that ignites humanity's yearning to seek extraterrestrial life. After many research projects and exploratory missions, the answers we receive still do not satisfy our expectations. Are humans truly the only beings existing in this vast universe? Or is there another form of life waiting to be discovered somewhere among distant planets? Now, our hopes are turning toward the moon's south pole, where permanently shadowed and ancient icy regions may hold the answer to one of the biggest mysteries. Why is this location so highly sought after? What discoveries at the lunar South Pole have reignited humanity's hope? Are we about to enter a new era where extraterrestrial life is no longer just a dream? Our journey to uncover the truth begins right now in today's video. The South Pole of the Moon. The key to extraterrestrial life, the Moon, the Earth's only natural satellite, is one of the most familiar celestial bodies to humankind. It is believed to have formed around 4.5 billion years ago, following a giant collision between the early Earth and a Mars-sized celestial body called Theia. From the debris of this impact, the Moon gradually formed and stabilized into orbit, with a radius of approximately 1,737 kilometers. It is the fifth largest moon in the solar system and has about 1/6 of Earth's gravitational pull. The Moon consists mainly of three layers: crust, mantle rich in minerals, and core. Its terrain was shaped by impacts and volcanic activity in the past, creating impact craters, lava plains, and mountain ranges. Thanks to its unique position, the Moon became the first celestial body humans studied and explored. Since Armstrong's historic step, humanity has launched numerous expeditions here. As of now, music, we have nearly completed exploring this world. Most experts and the general public agree that the Moon is unlikely to support life. However, this perception might change in the future as scientists focus their research on a special area, the lunar South Pole. Does this region resemble Earth's cold South Pole? Why is it said that it could change our views on extraterrestrial life? First, let's examine its geography. The lunar South Pole stands out for its rugged terrain and concentration of large impact craters. Among these, the most notable is the South Pole Aitken Basin, SIA, the largest impact crater not only on the Moon, but in the entire solar system. Measuring approximately 2,500 kilometers in diameter and 8 kilometers deep, it was formed from an enormous asteroid impact billions of years ago, exposing deeper geological layers beneath the surface. This feature allows us to better understand the Moon's mantle, extract resources, and deploy long-term exploration equipment. Additionally, the South Pole contains many permanently shadowed craters due to the Moon's axial tilt of only about 1.5 degrees sunlight never reaches the bottoms of these craters. Their temperatures are extremely low, minus 240 degrees Celsius, making them ideal for preserving water ice and volatile compounds over billions of years. Moreover, the lunar South Pole may contain valuable resources, including helium-3, a rare isotope accumulated from solar wind. Helium-3 has potential applications in nuclear fusion reactors, offering clean and highly efficient energy. If we can harness it, humanity will gain a new abundant resource for development. Beyond mineral wealth, the South Pole serves as a natural laboratory for scientific research. Large impact craters and deep mantle materials could contain important samples. Analyzing them would help us learn more about the Moon's evolution, as well as Earth's history and other planets in the solar system. Many compounds preserved intact in the permanently shadowed areas allow us to recreate the chemical conditions of the early solar system and environment Earth itself cannot preserve due to geological activity. Because of these factors, exploring the lunar South Pole has become essential. It represents a major advancement in science and technology and opens up opportunities for humanity's future. Interest in this special region has driven countries and space agencies worldwide to plan lunar missions. India is one such nation with strong aspirations. As early as the 2000s, the Indian Space Research Organization, ISRO, began developing spacecraft to study Earth's only natural satellite. Now the Chandrayaan-1 project, Mooncraft-1 in Sanskrit, was born, programmed to perform three main tasks mapping the lunar surface, studying minerals, and searching for water. This mission marked the beginning of India's journey to explore the lunar South Pole. On September 28, 2008, Chandrayaan-1 was successfully launched from Satish Dhawan Space Center aboard a PSLV-C-11 rocket. After complex orbital adjustments, the spacecraft entered lunar orbit on November 8th, beginning its 300-day mission conducting numerous experiments and observations. One of Chandrayaan-1's most significant contributions was detecting water ice within the permanently shadowed craters at the lunar South Pole. Let's pause here to understand what water ice is. It forms over billions of years through various sources protons from solar wind, interacting with metal oxides on the lunar surface, create hydroxyl, which then transforms into water. Past asteroid and comet impacts may also have delivered water. At the South Pole, deep craters create permanently shadowed areas where sunlight never shines. And extreme cold helps preserve water ice in stable form over long periods. Why is this discovery considered groundbreaking? Finding water ice holds immense scientific, economic, and strategic importance. It could be processed into drinking water, paving the way for long-term human habitation on the moon. Water ice extraction could reduce costs for space missions, serve as rocket fuel, and provide oxygen for astronauts returning to Earth. Returning to Chandrayaan-1's journey. Besides water ice, the Indian probe also detected iron oxide and minerals like olivine and pyroxene. These valuable data enhanced understanding of the moon's composition. It also mapped the South Pole's terrain in detail, providing temperature data, lighting conditions, and resource potential, all foundational for India's subsequent lunar missions. 11 years later, in 2019, the world resumed lunar missions, with Chandrayaan-2 targeting the South Pole. Despite high expectations, it crashed upon landing. Undeterred, India launched Chandrayaan-3 successfully, landing at the lunar South Pole with more advanced technology. This achievement further intensified India's focus on exploring water ice. Besides India, the United States also pursued lunar South Pole missions. On November 16, 2022, Artemis 1 marked America's impressive return to leading space activities after more than half a century since. Apollo 17, the last time humans set foot on the moon in 1972. Artemis 1 was an uncrewed mission primarily aimed at comprehensively testing the new Space Launch System, SLS, and Orion spacecraft. Additionally, it was the first step toward realizing broader ambitions to establish a sustainable human presence on the moon and lay the groundwork for Mars exploration. Its immediate goal was to send Orion into lunar orbit and study the moon's south pole. After 25 days, 10 hours, and 53 minutes, Artemis 1 concluded successfully, marking a major milestone for humanity. It continued the story of human exploration, opening new horizons and inspiring future missions. So, after all these explorations, what do we know about the lunar South Pole? A major unanswered question remains. Does life exist in this special region? The lunar South Pole shares similarities with Earth's South Pole. Both are extremely cold and contain water ice. Some people speculate whether life could exist beneath the ice. Indeed, on Earth, extremophiles' tiny organisms capable of surviving harsh environments have been found in Antarctic ice, volcanic vents, and even arid deserts without water for centuries. These findings suggest that life can thrive under previously deemed impossible conditions. Could similar life forms exist on the Moon's south pole? While the Moon lacks an atmosphere and faces intense radiation, its permanently shadowed craters might offer relatively stable conditions. Water ice, whether solid or liquid, is a critical factor supporting life. Extremophiles on Earth use ice as a hydration and nutrient source. Additionally, some terrestrial microbes can withstand radiation levels thousands of times higher than humans. If they exist on the Moon, they might survive and even thrive in the harsh polar environment. Thus, the hypothesis of extremophiles on the Moon gained support from many experts. To make this plausible, we must ask, how could microorganisms survive on the lunar South Pole? Unlike Earth, organisms on the Moon would need special adaptations. First, they'd require protective membranes, pigments, or antioxidants to shield cells from radiation. DNA repair systems would also need upgrades to handle damage from energetic waves and extreme temperatures. A survival mechanism many Earth microbes possess is entering a dormant state. Metabolism halts almost completely, allowing survival for centuries in harsh conditions. Additionally, if extremophiles live at the lunar South Pole, they could utilize lunar minerals as an energy source. Chemical processes between microbes and minerals could generate the energy needed for survival. Most importantly, if life exists on the Moon, there would be no oxygen for respiration. However, many Earth bacteria survive without oxygen, like anaerobic bacteria using nitrate or sulfate instead. Thus, lunar microbes might evolve similarly. Therefore, the extremophile hypothesis raises important questions about life's adaptability in extreme environments. Based on what we know about extremophiles on Earth, we can imagine similar mechanisms supporting life on the Moon. But is it feasible? To verify this hypothesis, scientists must apply modern scientific methods and advanced space technology. One of the most direct ways is collecting soil and rock samples from the lunar South Pole. Robots and spacecraft can gather material from permanently shadowed craters and return it to Earth. Experts can then use techniques like PCR, DNA analysis, or electron microscopy to search for microbial traces, cell structures, or nucleic acids. Chemical analysis can identify organic compounds indicating biological signatures. The Moon contains minerals like sulfur, iron, and metallic compounds that extremophiles could potentially use for nutrition. Studying these minerals in lunar soil can determine if the environment supports life. In addition to sample collection, synthetic biology and microbiology technologies can simulate Moon-like conditions in labs. Scientists can observe adaptation, survival, and growth patterns before drawing conclusions. Space-rated biosensors integrated into spacecraft and rovers can also conduct in situ tests on the Moon, eliminating the need to return samples to Earth. Another verification method involves analyzing radiation resistance. The Moon's thin atmosphere offers little protection from cosmic and solar radiation. Scientists can assess extremophile survival rates by simulating high radiation environments in labs using UV rays and cosmic particles. Furthermore, identifying organic compounds, especially carbon-containing ones in lunar samples, could indicate microbial presence. Researchers can use infrared and Raman spectroscopy to detect these quickly. Verifying the extremophile hypothesis requires advanced technology and complex analytical methods. If evidence is found, humanity gains a new perspective on the Moon and extraterrestrial life. However, each method has limitations. Simulations can't perfectly replicate lunar conditions, and lab environments may differ from actual space settings. Thus, the only definitive solution is to go there ourselves and study firsthand. Hence, numerous spacefaring nations have planned and continue to plan missions to the lunar South Pole. One such mission is Artemis 3. Following President Donald Trump's signing of Space Policy Directive 1 in December 2017, NASA initiated this ambitious endeavor. Artemis 3 will mark humanity's return to the moon after more than 50 years since Neil Armstrong's historic steps. NASA has announced many goals for Artemis 3. Astronauts will visit the lunar South Pole to collect soil and rock samples, study geology, and assess water ice distribution. For this grand mission, NASA will use the SLS, the most powerful rocket ever built, to carry heavy payloads and deliver sufficient energy for Orion spacecraft to reach lunar orbit. Alongside the astronauts will be the modern and safe Orion spacecraft. Additionally, specially designed spacesuits will aid mobility on difficult terrains like the lunar South Pole. According to NASA reports, Artemis 3 is scheduled for launch in 2025, perhaps just a year away. Humanity will soon gain deeper insights into this special region. Will life exist at the lunar South Pole? From the Artemis 3 mission, NASA scientist Prabal Saxena proposed another intriguing hypothesis about extremophiles possibly existing on the moon. Currently, most accept that the moon isn't suitable for life. However, if Orion and its crew successfully land at the South Pole, extremophiles brought from Earth might survive. This seemingly wild hypothesis has gained traction among experts. Saxena suggested that permanently shadowed regions at the lunar South Pole, never exposed to sunlight and shielded from solar radiation, could offer ideal environments for extremophiles. These areas could protect microbes from extreme cold and radiation, enabling survival in harsh conditions. A key part of Saxena's hypothesis involves studying Earth-based extremophiles, which have proven survival capabilities in extreme environments, from ocean depths to frozen wastelands and hydrothermal vents. According to Saxena, these microbes could potentially survive similar conditions on the moon, especially given the presence of water ice. Recent studies show that lunar South Pole craters may contain water ice in permanently dark areas protected from radiation. This ice isn't just a valuable resource. It could provide a habitat for extremophiles. Though Saxena's idea remains theoretical without direct evidence, it opens new possibilities for discovering life in extreme environments. Perhaps when Artemis 3 succeeds, his hypothesis will finally be tested. When Saxena's theory was published, many scientists expressed skepticism. They preferred evidence over speculation. Dr. Jennifer Eigenbrode, an organic geochemist at NASA's Goddard Space Flight Center, agreed that while meteorites might not reliably transport microbes, crude missions like Artemis could inadvertently bring spores to the moon. These spores might survive in permanently shadowed craters with stable temperatures and radiation shielding. Eigenbrode hopes Artemis will uncover vital resources like water and carbon, enabling microbial survival and growth. However, she also raised concerns about contamination risks. She pointed out that increased exploration of the lunar South Pole could pollute the environment. Emissions from spacecraft and astronaut equipment might release carbon dioxide, water vapor, and other harmful gases. Substances toxic to potential microbes. Carbon dioxide, for instance, is antimicrobial and could inhibit microbial growth. She also highlighted issues regarding environmental changes during life detection experiments. As space exploration expands, increased lunar traffic could alter conditions, releasing substances that skew research results. This emphasizes the need for strict control over human impact during missions to avoid compromising scientific integrity and protecting extraterrestrial environments for research. Through Eigenbrode's insights, many agree that life might have existed on the lunar South Pole, but was affected by human influence. While thought-provoking, without reliable data, this remains speculative. Meanwhile, conspiracy theories surrounding the lunar South Pole attract significant attention. One popular theory suggests extraterrestrial civilizations once or still exist in permanently shadowed regions. According to this view, the moon isn't just a barren rock, but was inhabited by alien life long before humans began studying it. Conspiracy theorists claim space agencies like NASA may have hidden evidence of extraterrestrial life, explaining why no country returned to the moon after Apollo missions until now. They speculate that the U.S. wants to keep information about alien life secret. Another theory posits the existence of alien bases built by extraterrestrials or ancient civilizations from other star systems. Supporters cite strange objects or geometric structures visible in images taken by spacecraft or satellites allegedly non-human in origin. Lastly, some theories focus on biological potential within the lunar South Pole's shadowed regions, suggesting tiny microbes or life forms may already exist there, undetected by scientists. Interestingly, these ideas mirror what scientists suspect and study, just framed differently through physics and biology. In conclusion, although no scientific evidence supports these conspiracy theories, stories about life on the moon's South Pole capture public imagination. Regardless, they reflect humanity's curiosity and desire to explore the unknown. Let's hope missions like Artemis continue to illuminate the moon's mysteries. Perhaps one day, this enigma will be solved, offering clearer insights into life beyond Earth. The lunar South Pole, with its icy craters and water ice reserves, has recently become a focal point for research. Do extremophiles exist there despite the harsh conditions? Or is the moon merely a cold, barren, and empty landscape as we've always imagined? If life exists on the moon, what would it look like? Would it give humanity new clues in the larger puzzle of cosmic life? Are we truly alone in this vast universe? Though these questions remain unanswered, they continue to burn brightly in every curious heart. The moon is not just a distant land. It symbolizes humanity's relentless curiosity. In this journey of exploration, what matters is not just finding answers, but having the courage to ask the questions themselves and continuing forward. Asterisk, hello everyone. We've completed today's video, and I appreciate your support. Give this thumbs up and share it with friends. Subscribe Mr.Bit UT channel and stay updated with our latest content. Your feedback and comments are valuable, so feel free to comment below. We're always enhancing and refining our videos. Thanks for tuning in. See you in the next one.